Thank you very much. I greatly appreciate the opportunity to talk to you. I regret that I could not personally come there, but I do want to thank Heston Carvalho and Mr. Hudson Mendonça for inviting me to make the presentation that you can see the cover slide. So please go to the next slide. I have to have my own slides as well. So what I'm explaining in this slide that the concentration of carbon dioxide in the atmosphere was 315 parts per million in 1960, 416 in 2020, 418 in 22, 420 parts per million in 22, and at present, today, it's 430 parts per million. So the concentration of CO2 is going up tremendously. Between 1850 and 2024, the fossil fuel emission is 500 gigaton, petagram. The land use change has contributed 255 petagram. And the soil has contributed to the total 745, another 135 petagram. So 745 plus 135, it's almost 800 petagram, gigaton, billion ton of carbon contributed since 1850. Of this, atmosphere has absorbed 310, ocean has absorbed 195, the terrestrial ecosystems have absorbed 250, and of course there's unaccounted for about 5. So if the terrestrial biosphere can absorb 250 without human intervention, is it possible to absorb more? Of course, we must reduce the emission, but can the land use sink be improved more? As a result of these emissions, the global warming since 1750 is already 1.5 degrees centigrade. And since 1970, the rate of change of global warming, rate of change of temperature, is 0.2 degrees centigrade per decade. So between now and 2100, at this rate, there may be additional 1.2 to 4.1 degrees centigrade warming. And that's a serious issue. If we can estimate the amount of fossil fuel which can be emitted, so we take the double than the pre-industrial era, that's 560, minus 430, what is today, multiplied by 2 gigaton per 1 part per million. So we can maximum burn 260 gigaton. The question is, how do you divide this 260 gigaton pie into 8.2 billion people of the world? That is the issue that is very critical. Can we find substitute biofuel? Like Brazil is very successful in sugarcane-based ethanol. Brazil has also a greater success story. We call it the Cerrado Miracle. The Cerrado Miracle refers to significant transformation of Brazil's Cerrado region into a major agricultural powerhouse for enhancing production of crops such as corn, soybean, cotton, representing 60% of Brazil's agricultural output. And this transformation is attributed to improving management of soil health and development of new crop varieties. Brazil is contributing significantly to global export and food security. And from this point of view, I'd like to congratulate each one of you, your scientists, your farmers, who have been very successful in bringing up this transformation. Between 2010 and 2024, the rate of growth is 6.2% per year for crops, 0.7% per year for milk, 1.6% per year for beef, and this has brought about the transformation. So, agriculture of the Brazilian farmer is a world agricultural powerhouse. Since 1960, Brazil transformed from a food importer to the largest net food exporter country of the world. Brazil is now among the top 5 world producers of some 36 agricultural products. And the output of agriculture has quadrupled, gone up 4 times since 1960, and is growing about 3.5% per year. And this transformation is called the Cerrado miracle. And it is one of the most important developments in modern world history. So I really congratulate you. I wanted to be there in person to congratulate you on this great success. Here's an example. The total food production of Latin America and Brazil. In 1960, Brazil produced 44 million tons of total food. And in 2024, it produced 515 million tons. Compared to Latin America, the rate of growth of Brazil is very large. As you can see, Brazil is producing more than 50% of the total Latin America. If you look at the total food export between 1960 and 24, in 1960, Brazil exported 5.5 million tons of food. In 2024, it exported 255 million tons. That's a factor of 50. The increase from 1960 to 24 is 50 times, 50 times. That's a great success story. Brazil's share of agricultural export for orange juice, 71%. Beef, 28%. Coffee, 33%. And poultry, 36%. Soybean, 58%. And corn, 23%. It's a remarkable transformation, a great success story, and hopefully we can repeat this in other parts of the world. Sugar, 52%. Swine meat, 14%. This is a remarkable success for which all the farmers, all the scientists, all the business community, all the policymakers, please receive my compliment and my congratulations. In 2025, Brazil is exporting 3.6 million tons of beef. Again, an export accounts for 30% of all beef production in South America. And that is an example of great success. Now, let's look at the causes of this increase in production, especially in the Cerrado. A part of the increase in production is due to efficiency improvement. A part. But majority of the farms have boosted production through greater resource use, through greater inputs of fertilizer, greater input of pesticide, greater input of irrigation, greater input of other inputs. And therefore, the question arises, can similar improvement in savanna of Africa, can it be applicable? Or will it have a too high a risk of resource cost, too high cost of the resources, and the Africa may not be able to afford? I think this is the discussion that's very pertinent in the meeting today. Brazil has now very good paved roads. Africa does not. So can the limitation of agricultural growth because the road transport be a problem if we were to repeat this experiment in Africa? There are some other negative effects also. Global warming, soil degradation, water eutrophication, water pollution, and the loss of biodiversity. Global warming, human activity has raised atmospheric concentration by 53% since 1750, 280 parts per million to 430 parts per million. The average global temperature has already increased 1.5 degrees centigrade since 1750 and a more rapid trend since 75. The majority of the warming has occurred since 75 at roughly about 0.2 degrees centigrade per decade. Can we afford to continue this global warming? Can the planet Earth afford to continue this rate of global warming? And the food systems have contributed 1/3 of the total warming. So Brazil could make another great success by making agriculture a solution to climate change. Biodiversity in Cerrado, over 50% of the Cerrado native vegetation still remain intact. And this is remarkable. I hope you continue keeping 50% of the vegetation as nature. Almost 30% of the land in Cerrado is used for agriculture. Do not expand. Cerrado houses 5% of the planet's biodiversity. The Cerrado has more than 11,500 plant species, nearly 500 bird species, 1,200 fish species, 300 species of mammals, 180 reptiles, and more than 100 amphibians. 4,800 of these species are found nowhere else in the earth. Therefore, protecting native Cerrado is very important. More than 130 species of animals in the Cerrados, unfortunately, are threatened with extinction. And we must hope that this will not happen. How do you mitigate the negative effects of agricultural intensification? Policies aimed at specific environmental goals, innovative research, education. I think these are some of the options we have. One of the important options is nature-positive soil agronomic practices, protecting, managing, and restoring soil, strengthening biodiversity, improving water quality and renewability, adopting negative emission farming, reducing input of chemicals, using biostimulants and organic amendments, promoting a biocircular economy, supporting the One Health concept, health of soil, plants, animal, people, ecosystem, and the planet is interconnected. And finally, using precision agriculture, digital innovation, artificial intelligence. I think these are the practices we must adopt. And we must consider that soil is a living entity. And as a living entity, it has rights to be protected, to be managed properly and judiciously so that it is not subject to degradation. Soil carbon and sustainable development goals of the Agenda 2030 are also interlinked. Soil health has a primary impact on goal number 2, end hunger. Goal number 13, climate action. Goal number 15, life on land. And there are many other goals, such as goal number 1 and poverty, which is secondary impact. Goal number 3, good health. Goal number 6, clean water. And goal number 7, renewable energy. And Brazil has done remarkable success in renewable energy, sugarcane ethanol, as an example. So, soil health has important role to play in sustainable development goal. That brings me to the question of agriculture revolution 4.0, which is artificial intelligence. Since circa 2010, artificial intelligence, cyber physical systems, or intelligent computers are becoming very important. Precision agriculture or digital agriculture revolution is driven by the urgency of change from performing, that means high productivity, to transforming, producing more from less. And this is where artificial intelligence can be very important as a tool for transforming Brazilian agriculture. Some of the examples of using artificial intelligence in the Latin America and the Caribbean region: Argentina, use of IoT to monitor grape health and quality. In Brazil, using smart sensors to optimize soybean production. In Colombia, to predict coffee harvest time, optimize irrigation systems, automate machinery. In Mexico, autonomous drones for crop monitoring and pesticide application. And in Peru, a robotic system to harvest potatoes. These are some of the success stories. And the benefits of AI: high use efficiency of inputs, reduced waste, increased yield, reduced input, especially labor, minimal human error, and of course, enhanced worker safety. Worker safety is very critical. But there are challenges of using AI. High initial investment cost is a challenge. We need skilled labor. We need for a reliable internet connection and extensive data. We need concerns about data privacy. We have potential job displacement. And of course, we have ethical consideration. So these are some of the challenges of using AI, which we must be aware of. Improving efficiency: autonomous tractors, drones, robotic harvesters, and weeders. So AI has a future role to play. It has a bright future, especially in Brazil and the Lake region. Advanced sensors, AI algorithm, next generation robotics to optimize agriculture processes, and restoration of soil health and protection of natural resources. Then we talk to sustainable soil management agriculture as a solution to global issues. And Brazil can play a very important role because soil is the most important natural resource on which the entire agriculture production depends. Soil health is vulnerable to intense degradation, which is a global problem facing humanity and including in Latin America and Brazil. Therefore, there is an urgent need to identify site-specific management practices and policies for protection, restoration, and preservation of the precious soil resource. I showed you this slide before. Soil is a living entity. The link between soil health and the life is very critical. We know that rhizosphere is the only site in the universe which has the capacity to resurrect death into life. And as Dr. Charles Kellogg of USDA stated, there can be no life without soil and no soil without life. They have indeed evolved together. So we must protect soil biodiversity. We must protect the living organisms in soil. We must increase carbon in soil. And there are two types of carbon: the humus, organic carbon, the upper part, and the inorganic carbon in the drier climate, arid, semi-arid region, in the subsoil. And soil health is really the capacity of a soil as a dynamic and biologically active entity to sustain ecosystem services for human and nature. So Brazil's agriculture now has a challenge how to maintain, sustain, and improve soil health on a continuous basis. Organic matter content: the optimum level is between 2.5 to 3.5%. Organic carbon about 1.5 to 2%. And you look at the soil of the developing countries and the relationship between organic matter content and crop yield, it plateaus at about 2.5%. But most soils of the developing countries, such as in the Caribbean, in part of Central America, in the Andean region, the organic carbon content may be less than 0.5%. And therefore, there's a need to improve it. And this is the soil human health nexus, because soil health depends on organic matter content and human health depends on soil. So the human health part, there are direct effects because of ingestion, inhalation, absorption, and there are indirect effects on human health due to quantity of the food, quality of the environment. So the question which I hope you will discuss is how to manage soil health. We must protect and restore soil. We must restore soil organic matter content. We must enhance soil biodiversity. We must live in harmony with nature. We must observe the law of return. And we must treat soil like a bank account. Treat soil like a bank account. You cannot take out from bank more than what you put into the soil or into the bank. The same thing applies to soil. So managing soil health by AI, which I talked already, regenerative agriculture, digital agriculture, robots and drones, biofortification, soil water energy nexus, breeding new soil, urban soil farming, nature positive agriculture. These are all important solutions to mitigate climate change. And Brazil can set an example how to do that. I mentioned the law of return, and the law states that substance we take from nature must be returned to the place from which it was taken. So whatever we take from land, we must put it back in one form or the other. That's the law of return. And finally, I want to talk about farming carbon. Just like you grow soybean, you grow wheat or rice or cotton, you also grow carbon in soil. And this carbon growing can bring income for farmers. So growing soil carbon as a commodity that can bring another income stream for farmer is called farming carbon. And that is a subject which will create a positive carbon budget. So carbon sequestration means adding carbon as biochar, compost, cover crop, root biomass, crop residue must always be more than the losses by erosion, leaching, decomposition. And if a system in which the gains are less than the losses, then we lose carbon. So extractive farming practices are depleting the carbon, which we must stop. Finally, as a model, we must manage soil health. We have improved varieties. We have plants which can emit molecular-based signals that you can detect when a crop has some kind of biotic or abiotic stress. And this plant has a deep root system. It is associated with the mycorrhiza and other rhizobium. This plant should be grown by no-till with a mulch and cover crop. And as the soil health improves, we must also use integration of plants, crops with trees and livestock. And this will lead to improvement in soil carbon, soil biodiversity improvement. It will have disease suppressive soil. And if we need to make inputs of NPK, zinc, water, that should be applied through drip fertigation in such a way that everything is absorbed by plants and very little leakage into the environment. So environmental pollution must be reduced. The technical potential of carbon sequestration in the world by improved agriculture is about 2.5 billion tons, gigaton, petagram of carbon per year. Between now and 2100, the technical potential of soils of the world is about 178 petagram of carbon, and of the vegetation like forest, trees, savanna, 155 petagram, total about 333 petagram, which has a drawdown of CO2 of 157 parts per million. Therefore, if we can stop fossil fuel combustion soon and do agriculture in a best way possible, keeping global warming to less than 2 degrees centigrade is still possible. And this brings me to the question of what are the farming practices which can emit less carbon. For example, moldboard plowing is 15.2 kilogram of carbon equivalent per hectare if you use diesel. Now, if you have Brazilian sugarcane ethanol, obviously that does not matter. Chiseling, 8 kilogram of carbon equivalent. Heavy disking, 8.3. Standard disking, 6. Subsoiling, 11. Cultivation, about 4. Rotary hoeing, about 2. So choice of tillage system can also reduce emissions. Then there's the cost of fertilizer. Nitrogen, about 2 kilogram of carbon per kilogram of nitrogen by the Haber-Bosch process. So improving nitrogen use efficiency is very critical. Phosphorus, less. Potassium is less. But herbicides are very expensive, very carbon intensive. Some herbicides can use 13 kilogram of carbon per kilogram of active ingredient. Same thing applies about kilogram of carbon per kilogram of active ingredients. So improving use efficiency of nitrogen and of herbicides and insecticide is very important. Fungicide, same thing as insecticides. There are other herbicides like atrazine uses 4 kilogram of carbon of active ingredient, dicamba about 6, glyphosate about 9, paraquat about 9. So minimizing the use and improving the efficiency of fertilizer, herbicides, pesticides, irrigation is very important. This is called carbon farming. And for this, the farmer should be rewarded. How much? $200 per ton of carbon or $50 per ton of CO2. $50 per ton of CO2. So one credit, 50 US dollar. Who should pay? I think it can be private sector, it can be government organization, but this is a private sector can play a very important role. Your community, business organization. So the private sector can be helpful in promoting nature positive agriculture, in increasing access to inputs, in improving investment in agriculture, research and development, and translate science into action, translating science in. I also mentioned that soil is a living entity, so there should be rights of soil. Rights of soil. Just as universal rights of human, rights of animals, there must also be rights of soil and rights of nature. Being the essence of all life, soil must have rights to be protected, restored, thrive, and managed and grow carbon in soil. And for this, we need Soil Health Act. In the US, for example, we have Clean Air Act. It was in 1967. We have Clean Water Act. It was in 1972. We need a Soil Health Act, which means rewarding farmers who restore, protect, and sustain soil health. Rewarding farmer is more important to improve agriculture as a solution. Finally, I'd like to mention that agriculture is not just for food, agriculture and soil are also for world peace. Global peace is a scientific issue. It's a political issue, yes, but it's also a scientific issue. Therefore, advancing science of soil health, promoting nutrition-sensitive agriculture, food processing and biofortification are critical and high-priority scientific issues with a strong impact on world peace and stability because they build bridges across nations. So, agriculture is not just food security and quality of nutrients in the food quality and water quality and climate change. Agriculture is also important to bring peace and stability in the world. Therefore, the final mantra that I would like to leave with you is healthy soil equal to healthy diet, equal to healthy people, healthy ecosystem, and healthy planetary processes. I hope that you could hear me, and if there are any questions, I'll be glad to present and discuss them with you.